Today we're going to start working hands-on with Python. I'm going to teach you about arithmetic operators and also about data types. I'm going to show you how you can use the Python interpreter as a glorified calculator. Arithmetic operators sounds scary, but you already know what these things are. You use them every day. Addition, subtraction, multiplication, division. These are all things called arithmetic operators. What arithmetic operators do is they operate upon operands. Operands are the numbers involved in the calculation. So 1 plus 1 equals 2, the ones are your operands. The plus is the operator. In Python, we have more than just the operators that you're used to in math class. We have ones for floor division, we have ones called modulus, we have different operators that are used for exponents. So I'm going to walk you through how operators work. Make sure that while you're watching this video, you follow along. I'm going to be using idle, and I'm going to be typing commands at the interactive prompt to show you exactly how to use the interpreter as a glorified calculator using arithmetic operators. Start by launching idle. We're going to test out these operators and how they work. 2 plus 2, that gives us 4. 2 minus 2, that gives us 0. What about multiplication? 2 times 2. Let's try division. 2 divided by 2 gives us 1.0. What about exponents? Let's try to cube 2. Let's try to raise 2 to the 3. That should give us 8 because that's 2 times 2 times 2. We're going to try some of the tricky ones now. Let's do modulus. Let's do 10 modulus 6. This is going to divide 10 by 6 and give us just the remainder. What's left over? 4. Let's try floor division. 10 floor division 6, which is how many times does 6 completely go into 10? Which is 1. That brings us back what we call the quotient. So modulus gives you the remainder. Floor division gives you the quotient. So these are very common in computer science, this modulo operator and this floor division operator. So now you've gotten valuable experience using the Python interpreter as a glorified calculator. All you have to do is enter in your command at the interactive prompt, what looks like the 3 greater than symbols, and press enter. When you do that, your command will be interpreted and executed immediately, and the output will be presented on the screen. The next thing we're going to talk about are data types. Most programming languages have data types. What is a data type? A data type classifies what a particular type of data is and what operations can be performed on it. This is extremely important because computers process information totally different than human beings, and the type of data can dictate what can be done to it. And I'm going to show you a quick example. So let's dig into this concept a little bit further. Let's say I'm working with whole numbers like 2. Can I raise 2 to the 3? Absolutely. Those are the kind of operations that I can do with numbers. But what about text? What about the character 2, like the one I type on my keyboard? Can I raise it to 3? No. If I try to do that, Python complains and says, wow, you've got unsupported operand types, that you're using the wrong type of data for that operation. So data types are very important. What if I tried to do something even dumber? What if I tried to take the 2 character and the 3 character and I tried to raise it that way? Same thing. It'll complain because you simply can't do that with textual information. You can only do that with numbers. What about if I add these 2 pieces of text? 2 plus 2 in this case becomes 22. But if I try to add 2 numbers, 2 plus 2 is 4. So as you can see, there's a big difference between numerical information and textual information. And that's what we're going to talk about next. Every piece of data, every value that you use inside a Python program has a data type. You don't have to tell Python what the type is. It will figure it out for itself and it will track it internally. The Python language has many built-in data types, and all of these data types are categorized. Some of the categories are numerics, sequences, mappings, etc. We're going to be focusing on the big ones, the ones that you really need to know. The Python language has a lot of different numeric data types. The ones I want you to focus on are integers. Integers are whole numbers. You're used to this from your math class. Integers are whole numbers, including 0 and negatives. Same thing in Python. Floats, so-called floating point numbers, are numbers that have a fractional part, like decimals. You can think of pi as being a float. One data type that all programmers need to be familiar with is called a Boolean. A Boolean is actually an integer data type. We've already talked about how computers store information as ones and zeros, where 1 represents true and 0 represents false. Booleans are the data type that is used to represent any information that can be classified as true, false, yes, no, on, off, 1, 0. In programming, keeping track of ordered information, like lists, is extremely important. The same is true for Python. Python has a variety of different data types that are called sequences. Sequences are what they sound like, ordered lists of information, things that happen in a sequence. The most important sequence that you're going to need to know is what's called a string. Strings are sequences of characters used to represent the textual information that we want to work with. Strings are the most frequently used data type in Python. Strings are normally enclosed in double quotes or single quotes. That's how you know it's a string and not a number, for example. Strings are also used for non-printable characters like new line characters and tabs and backspaces. We don't normally think of this as textual information, but it is. You may be asking yourself, how will I know what the data type is for any given value? It's great that Python knows and stores it internally, but how will I know? Well, lucky for us, Python has something called the type function. The type function is something that you provide the data, and it will return to you what its type is. The idea of a function is pretty simple. It's very similar to what you're used to in math. It's something that's like a mini program. You provide it with some value, you ask it to do something, and it will return a value to you. In our case, we are going to provide the data to the type function, and the type function will print out the type for us. Like so many things, this is best understood through some sort of demonstration. So let's demonstrate the idea of how to use Python's type function. Let's practice using the type function. To use the type function, simply type the word type and then open parentheses. Inside the parentheses goes the value that you want to determine the type of, and then close parentheses. So the value of 1 is an integer. Let's look at the value of 1.5. That gives us a data type of float because it's a floating point number. It has a fractional part. It's important to note that if I looked for the type of 1.0, I would get a float as well because it has a fractional part. It doesn't matter whether the fractional part is 0. Let's take a look at the word hello enclosed in single quotes. That should be a string or just str. What about hello in double quotes? That also is a string or simply str. Let's try Booleans. Let's try the value of true. Notice how there's no quotes and it's a capital T. That is a Boolean. What's great about type is that you can actually provide it in an expression like 1 plus 2. That would result in a data type of int. What about 1 plus 2.0? Well, that would be a float. So this is how you not only use a function, but how you use the type function. You provide it the data and it gives you back the type.